what we need to know is the names of the salts. So the can type of ions that we have and the anions have. So the simple ones that you learned last time, okay? So for example, if sodium hydroxide reacts with hydrochloric acid, so the sodium is the cation, the chloride from hydrochloric acid makes sodium chloride, NaCl. Copper 2 oxide is the base, reacts with hydrochloric acid. So you make copper 2 chloride, okay, CuCl2. Sodium hydroxide, sulfuric acid gives a sulfate ion. So you make sodium sulfate. Zinc with sulfuric acid, you get zinc sulfate. Okay, now ammonia is a special kind of base. It forms ammonium salt, which is ammonium ions NH4 positive 1. So if it reacts, it forms ammonium chloride like this. Okay, so basically, there is a whole list of cations that can react with a whole list of anions to form salts. So, for example, potassium, sodium, calcium, magnesium, aluminium, zinc, iron 2, iron 3, lead, copper, silver, barium, chromium. Okay, so these are all called cations. So any of these cations can combine with any of the anions. So the anions are chloride, bromide, iodide, sulfate, and nitrate. Do they all look familiar? Okay. So can you write down this list of anions and this list of cations? This is not an exhaustive list. There's some more. It's just that we haven't learned yet. Sometimes we don't learn. Okay.
没说係 C2。
Chromium.
哦，
Are you done?
Done.
Okay. So, very important for these salts is you need to memorize whether it is soluble or insoluble. Okay. So, for example, as long as there's a night, so for example, I give you an example. Uh, Potassium with nitrate is potassium nitrate. Chromium with nitrate is chromium nitrate. Silver with nitrate is silver nitrate. Anything with a nitrate is called a nitrate salts. As long as it has a nitrate salts, all nitrates are soluble. That means they can dissolve in water. Okay? All sulfates are soluble. Okay? That means sodium sulfate, zinc sulfate, ammonium sulfate, they're all soluble. However, they are insoluble sulfates. So you need to remember these three. The three insoluble sulfates are barium, calcium, and lead. Hb, Bacha. That means only these three are insoluble in water. Okay? Chloride salts, again, if they say chloride, it also means iodide, it also means bromide. So chloride, bromide, iodide share the same thing. Okay? So here they are saying all the chlorides are soluble, however, this silver and lead insoluble. It means that silver bromide, silver iodide, lead chloride, lead iodide is also in that group that is insoluble. Okay, understand? Carbonates are the other way around. All carbonates are insoluble. Okay, calcium carbonate, copper 2 carbonate, all the carbonates are insoluble. However, if it has a potassium, sodium, and ammonium carbonate, only these three are soluble. Okay, this is very, very important chart, and this one you must memorize. Okay, I'm going to give you a few seconds to try and remember this, and I'm going to ask you questions. Okay, okay, ready? Ready
Okay.
now? You know? All right. Now, what does soluble and insoluble mean? Soluble is like that. Okay, for example, sodium chloride is soluble or insoluble?
Soluble.
So it means that when it dissolves in water, we will separate in the water, we will separate to form sodium and chloride ions. So when you put the solid salt inside, it will so-called disappear because it's soluble. Now, silver chloride, soluble or insoluble?
Insoluble.
So what happens is when you put it inside, the silver ion and the chloride ion love each other so much that they refuse to separate. So they look like a piece of solid inside. It doesn't dissolve, like sand like that. So if it's water, it's just a solid here. It doesn't dissolve. And a solid like this is called a precipitate. I'll explain in a while. Okay? All right. Copper 2 carbonate, soluble or insoluble?
Insoluble.
Okay. Magnesium sulfate, soluble or insoluble?
Soluble.
Okay. Do you understand what I'm talking about now?
Huh?
Do you understand what I'm talking about, soluble and insoluble?
Yes.
Okay, so why is it important to know whether something is soluble or insoluble? Because of the preparation of trying to make, all right, trying to make the salt. So in when you want to prepare a salt, first you have to check the solubility, and then if it's soluble, you check what kind of acid it has. Okay, so there are three methods to prepare a salt. The first method is called titration. Titration is only for potassium, sodium, and ammonium salts. Okay, so titration is specifically, do you know what's a burette?
Yes.
Okay, here's a burette, and then here's a flask, and then here in the burette you put the acid, and in the flask you put the alkali plus the indicator. Okay, so you titrate like that because acid is an aqueous solution, alkali is also aqueous solution. So this one has to be acid plus alkali gives you salt and water. So it's only potassium, sodium, and ammonium salts. Okay? So let's say I want to make potassium sulfate. Do I have to use titration method? Is potassium sulfate soluble or insoluble?
Insoluble. Potassium sulfate.
Ah,
Potassium sulfate. Soluble.
okay. Is it a potassium, sodium, ammonium salt?
No.
Dude, is potassium sulfate.
Oh
Potassium
yeah, it's
sulfate.
potassium salt.
Is it so? Is it? Do you use method one? Do you use titration?
Yes.
Okay, so titration is acid plus alkali. Can you tell me the acid to make potassium sulfate?
Sulfuric acid.
Okay. What is the alkali to make potassium sulfate?
Potassium.
Alkali. What is the alkali? What is an alkali? Look at last week's notes. Look at last week's notes. I had a whole lesson with you. What is alkali? Go and look at last week's notes. Did you copy last week's notes?
Yes.
Go and look at last week's notes. Don't need to stare at me. Go look at last week's notes.
Potassium hydroxide.
Thank you. So I will get potassium sulfate
And water.
which balance this equation and figure out what acid and what alkali should I use to make sodium nitrate and ammonium chloride. Okay? Balance the first equation first, huh?
2 KOH and 2 H2O.
Yeah, correct. Okay, do the other two. Are you done?
Last one. Okay.
So, what acid do you use here?
HNO3 plus NaOH. You get NaNO3 plus H2O. And then HCl plus NH3. Yeah.
Wait. So basically, anything to do with potassium, sodium, or ammonium salt, you have to do it this way. Understand?
Okay.
Okay. Now, if it's a soluble salt, but it's not this three, then you use a method called acid neutralization. Okay? Right. Wait. So I'm going to take a screenshot of this and I'm going to move it somewhere else. So let's focus on this. So just now we talked about, uh, so this is method one, okay? So let's focus on this first. All right. So let's say I want to prepare potassium sulfate, okay? In my burette, I would put sulfuric acid. What is the color of sulfuric acid?
Colorless.
Okay. Here I'll put a flask, conical flask, and I will put potassium hydroxide. What is the color of potassium hydroxide?
Potassium hydroxide. Uh, White.
Think again. Look at your notes. It's
Colorless.
colorless, yes. Okay. So because it's colorless and colorless, in order for me to know when it's neutral, I have to add an indicator. So in an example of an indicator I can add is, yes, what's an example of an indicator?
Methyl. No.
Methyl, yeah.
Methyl orange. Methyl orange.
Methyl orange. What's another one?
Thymol. Phthalate.
Okay.
And then litmus paper.
No, litmus cannot use for this. Okay,
Okay.
because I only want one. Litmus is not litmus paper, but litmus solution. Okay, what is the color of methyl orange in potassium hydroxide?
Yellow.
Okay, so now there's color. So I will add a few drops of potassium sulfuric acid, then I swirl. Then I add, then I swirl, then I add, then I swirl. I add until it changes color to become colorless. When it changes color to become orange, okay? When methyl orange becomes orange, that means it's neutral, all right? So now it is potassium sulfate plus water plus methyl orange. Okay, but if I want to prepare pure crystals of potassium sulfate, this is not pure crystals of potassium sulfate. It is potassium sulfate in water plus methyl orange. So how can I make pure potassium sulfate? How can I take away the methyl orange? The reason why I need methyl orange is I need to know how much acid reacts with how much alkali. Because acid is colorless, alkali is colorless, right? Okay, so the purpose of the metal orange is to give it color so that I can see the endpoint. Okay, so now we have a problem of I have metal orange. Okay, so how do I get rid of the metal orange?
How do you get rid of methyl orange?
Yeah, while still using the same concentration.
Filtration.
No, it's soluble one.
Dry the boiling method.
No. Think again.
Evaporation.
No, no. So I want to make sure I repeat the experiment. I already know what's the volume of sulfuric acid I use, right?
Huh?
Okay.
Okay.
Now, so what you should do is repeat the experiment. But this time, with the same volume, using the same volume as you use for hydration, but now without indicator. Okay? So now you have potassium sulfate solution. Okay? I want to make crystals. How do I change this into crystals? So we use the crystallization method. Now it's a solution, right? How can I change the solution into salt crystals? What can I do? Do you
Uh,
understand the question? Mm,
Evaporate the solution.
okay. Can you heat it up until it's dry?
Yes.
No, if you heat it up until it's dry, you don't get crystals. If you heat it up until it's dry, you get solid. You
Powder.
get powder. So you must heat it up until it's
Oh, means
saturated.
you want crystals now? Ah?
Yeah, I wrote here crystallization, crystals.
Okay.
Why are you so sleepy today? Are you sleeping?
No.
Okay, you heat using a Bunsen burner until saturated. What does the word saturated mean?
Saturated means
The
the amount
max,
of
no,
maximum
maximum
amount of
amount of,
particles.
no, solutes in a solvent at a given temperature. Because when you're heating it, less and less water, and you're getting hotter and hotter, the solubility increases. When it's saturated, means it's the maximum. So after you heat until it's saturated, you cool it. You cool the saturated solution. When you cool a saturated solution, crystals will start to form. Why do crystals form? Why do crystals form?
Because the particles becomes cooler and
Yeah,
then
so when it's cooler, then
hmm,
solubility increases or decreasing.
when it's cooler, solubility decreases.
Yes.
So the excess amount of solutes will become crystals.
Yeah, correct. So crystals form because solubility decreases, solubility decreases when temperature decreases. And then finally after this, you dry it between filtered paper. Okay?
Okay.
All right. Now we're going to go to the second method, other soluble salts. Okay. So this is acid neutralization method 2. If I want to make ammonium sulfate, method 1 or method 2?
Ammonium sulfate. Hydration.
If I want to make zinc sulfate,
Acid neutralization.
yes. So zinc sulfate would be method 2. So we're going to talk about this method now. Okay, so this one is something you learned last week. Acid neutralization is acid and metal, acid and base, but this base must be insoluble. Acid and carbonate. Okay, what do these three have in common?
Acid.
No, this one.
Uh, or alkali.
Think carefully.
When they react with acid, they produce a salt.
Yeah, correct. But what is special about metal, insoluble base, and carbonate? They are solid, liquid, or gas.
Solid.
Yes. So the three of these are all solid. So we cannot do titration. Huh?
No.
All three will give you salt. The first one is salt and hydrogen. The second one is salt and water. The third one is salt and water and carbon dioxide. Okay?
Okay.
So, so for example, I want to make zinc sulfate. Okay, write down the equation for me. Write all three equations.
Okay.
So,
H2SO4 plus zinc is ZnSO4 plus H2. And the next one is H2SO4 plus ZnO is ZnSO4 plus H2O. Last one is H2SO4 plus ZnCO3 is H2O plus CO2.
okay, got it?
Yeah.
Okay, so all of this is solid. Solid. Okay? But all of this is aqueous. All of this is solid. All of this is aqueous. This one is gas. This one is liquid. This one is liquid. This one is gas. Okay? Get it?
Okay.
How do we do this experiment? So, first you take sulfuric acid. So you add zinc or zinc oxide or zinc carbonate, whichever lah. Okay. Now, whichever three you add, the most important word is you must add it in excess. That's the most important. You must add it in excess. Why? Why must you add it in excess? You must add it in excess to completely neutralize the acid. So when you're done, you will have produced a neutral zinc sulfate solution. And this is the excess zinc or zinc oxide or zinc carbonate. Because zinc oxide and zinc carbonate can only dissolve in acid. It cannot dissolve in neutral. So you just add and add and add and add. So no need indicator, no need anything. And then step three is you just filter out the excess. And so here is zinc sulfate solution. Now, if you need to do crystals, then you go to crystallization, which is the same as just now. Can you understand?
Okay.
Okay, so now I want you to write equations. Write equations, you must write method 1 or method 2. Method 3 I teach you next week. You must write whether it's method 1 or method 2 and write the equation to prepare. Sodium chloride, magnesium nitrate, that's all. Okay, write down whether you use method 1, method 2, method 3, and then write down the equation.
Means method one, method two means either titration or acid neutralization.
Yeah.
So I just write there and then start writing the equation.
Yes.
Okay.
ZiHua, are you done?
Last one.
Okay, when you're done, you send me, okay?
Okay.
Okay. This one, this one, right? Can I use copper carbonate instead? ZiHua, this one, can I use copper carbonate instead? Do you understand my question?
Yes.
So can I use copper carbonate instead if I wanted to?
Yes.
Okay. Can I use copper?
Yes.
No, cannot. Remember, copper doesn't react. Copper and silver do not react with acid.
Um,
Uh,
copper, copper, silver, platinum, gold.
yeah. Okay, this one, can I use magnesium carbonate?
Yes.
Can I use magnesium?
Yes.
Okay. You get it?
Yeah.
All right. For this reaction, if I use the first one, the first one, what are my observations?
Bubbles, gas bubbles formed.
Okay. Some more? One more? The observation is same, the first one and the third one.
Heat,
No, heat is not observation.
color change.
No, this case no color change. Think again. Something to do with the reactants.
Reactants are used up.
So what do you see?
Reactants finish. Like they get less and disappear.
What is the reactants made of?
Solid.
Okay, so the solid dissolves. Understand?
Yeah.
Okay, so the second observation is the solid dissolves. So bubbling and then the solid, whatever lah,
Dissolve.
zinc oxide or zinc carbonate dissolves. In this case, zinc sulfate is a colorless solution. Okay, colored solutions are only those made from transition metals like
Okay.
copper, chromium, okay,
Manganese.
manganese, yeah. Okay, now next week I'm going to teach you uh, The third one. Okay. I'm going to send you two documents now. One document is the notes from just now, and another document is this one. Okay, this one, right?
Receive that.
Yeah, this one is what I just said. Okay, this one, right? We do it next week. So this one we continue next week.
Okay.
Wait, we continue. Okay, the one that I send you is this one. This one. Can you see this?
Yeah.
Okay, I want you to print it out and
Okay.
try and do the first two questions only.
Okay.
Okay? All right.
Like
I'll
the
see
new
you next
worksheet
week.
you sent me, ah.
Yeah, the new worksheet I
Okay.
send you. Okay? Try and do the first two questions only. All right? Okay, bye bye.
Okay. Bye bye.
Bye bye.